Okay, so since we reviewed our conversions and we reviewed graphing, we're going to start talking about our chapter on motion. And we're going to start that by talking about distance versus displacement. So I'm going to show you a small video. It's about 1 minute, and while you watch it, I want you to try to write your own definition of distance and write your own definition of displacement in your own words, and also draw an example of each. And do this on your...
In this video, we're going to discuss the difference between distance and displacement. Let's go to the left. We're following a path that's leading us to some destination. We're traveling a distance. We can measure this with different tools, avoid the trees, and rope curve there. And eventually, hopefully, find our path again. Yeah, there it is. We'll reach a destination. We've traveled a distance from our origin to the destination. Now, we'd like to go on a straight line path, of course. There's a mountain where we're mountains up the road. Alright, this works. Now we're going to be able to travel a displacement. A displacement starts in the same origin, but it travels in a straight line from our origin to our destination. This is usually much, much shorter. And there's our destination. We travel the displacement marked in green versus the distance marked in red.
Okay, so the definition of distance, we have, it's the length of a path between 2 points, right? So in your little video there, you saw the length of the path was that red line they drew, and you weaved in and out, and so to find the length, you'd have to measure that whole thing. We usually measure length in meters in the metric system, or the SI unit, and if you're measuring really long distances, you would use kilometers. Small distances, you would use centimeters. Super small, millimeters, right? Remember that 1,000 meters equals a kilometer, and 1 meter is equal to 100 centimeters. If you need to do any other conversions, just remember your King Henry. We want to look at the example of a roller coaster. We're going to use it again in a second. So to calculate the distance that you went, you would just need to know the length of the track, right? Okay, so let's talk about displacement. So displacement is the direction from the starting point and the length from in a straight line from the starting point to the ending point. And so we'll use direction. So like when you're giving directions on how to get somewhere, you're really using displacement. You don't just say you go 2 miles. You tell them which way to go. So that's the big key about displacement, is direction also. We're going to use the example of a roller coaster again. So you're going in a certain direction, right? If you go the wrong way, you'll run into another car. But the other thing here is that your total displacement after the ride is going to be 0, right? Because you're going to end up in the same place that you started with. Here's another visual, just to reiterate the point. So you're going to start right here, right? And then you're going to follow that blue path, and you're going to end right here. And the important thing for distance is you're going to measure that whole way. And then for displacement, you're just going to measure the distance from where you started to where you ended up. Okay, and then the direction as well. So we're going to talk about vectors really quickly. And vector is just has a quantity and a magnitude, and you can see a picture of a vector there below. If you've taken geometry, or you are taking geometry, you may have seen these. So a magnitude is just like a number, a size, a length, an amount. It's going to be represented by the arrow on your graph or your map. The length of the arrow is going to depend on the magnitude or the size of it. So bigger arrow for a bigger vector, a smaller arrow for a smaller vector. And the reason why we mention vectors at all is because displacement is an example of a vector. So we need to talk about how we're going to combine displacements, because it's not as simple as just adding and subtracting. So if you have two displacements, they're going to be represented by two vectors, and if they're going in the same direction, you're just going to add the magnitudes, add the numbers. So if we have 2 units going to the right and 4 units going to the right, you would just add those guys up and it would be 6 units going to the right. Okay, so that's easy enough. But if we have 2 displacements and they're going in opposite directions, it's going to be a little different. You're going to have to subtract those magnitudes. So we have 2 units going to the right, but we have 4 units going to the left. Okay, so we're going to subtract that, and they're going to go in the direction that the arrow is pointing that's bigger. So we have 4 minus 2 is 2, right? And it's going to go to the left because that number to the left is bigger. So 2 to the left. Okay, so let's take about, we're going to look at adding just for a little bit longer. So again, we have this car is moving 4 kilometers to the right and then moves 2 kilometers to the right. Okay, so you can probably figure that you're going to add these together, right? 4 plus 2, and that's 6, and to the right or east. Okay. So here's another one. So we have 4 kilometers to the right and 2 kilometers to the left. So those are opposite directions, right? So we're going to go ahead and subtract those. So 4 minus 2. And remember that it's going to be whichever direction the bigger arrow is. So that's 2, and then whichever direction. So 2 to the right or 2 east because that's the bigger arrow. Okay, so we have some sample problems here, so I'm just going to give you a couple minutes to look those over. Okay, so here we have 5 and 5 and they're in the same direction. So that's 10 and to the right, right? So then here we have 5 and 5, but they're in opposite directions. So they are going to cancel each other out, so it'll just be 0. So we have 5 and 10, and they're in the same directions, right? So if we just add them together, that's 15. 5 and 10, but they're in opposite directions, so you're going to subtract them. So 5, and that's to the left. And then we have 5 and 15, opposite directions, so we're going to subtract. So that's 10 to the left. And then here we have 10 and 5 in opposite directions. We have an up and a down, but it doesn't really matter what the directions are. So we have 5, and that would be up, right? 'Cause that's okay. We're going to use some geometry skills here. So you either have had geometry already last year or you're in geometry now for most of you. And so let's talk about that. So take a look at the picture. And we want to combine these displacements. So you have 10 kilometers going north, and then you have 10 kilometers going west. And so we want to combine that somehow. And so the resultant vector, or combining the vectors, creates this right triangle here. And so my question to you is, how do I find this length right here? And so I just want to give you a minute to think about that. What kind of skill could I use from geometry? And hopefully some of you have thought about it. And that would be the Pythagorean theorem. Okay. So if you remember the Pythagorean theorem, this is what it looks like. A squared plus b squared equals c squared. And if you remember, a squared and b squared cannot be the ones across. It can't be that one, but it can be either one of these. It doesn't matter what order you put them in. So I'm just going to call this A and this B. Okay. So I'm going to say 5 squared plus 10 squared equals c squared. Okay. So I'm going to say 5 squared plus 10 squared equals c squared. So 5 squared is 25, and 10 squared is 100. And that's c squared. And so if you add them together, that's 125. And that's not the answer. The answer is not 125. And if you just look at the picture, that would not make sense, right? If this is 5 and that's 10, if you just look at it, it should be a little bit more than 10. And if you do it on your calculator, you'll see that the square root of and you have to do square root, right? Square root of 125 is like 11 something. It's about 11 kilometers. And then direction, right? It's northwest. And you can write northwest in W if you want to. Okay. That's a little tricky. Let's try another. Okay, so here's one more problem, and we're going to use the Pythagorean theorem. And I know that because I have two vectors, and when they combine, the resultant vector here is going to make a right triangle. Okay? So here's the Pythagorean theorem for us, and it doesn't matter what we call A and B. I can call this A and this B. So I can do 40 squared plus 30 squared equals c squared. And 40 squared, so 4 times 4 is 16, so that's 1600 plus, and 9 squared, or 3 squared is 9, sorry. Okay, so if we add those together, that's 2500. That's c squared. Okay. Okay, so we got to square root this, you guys. So square root of 2500 is 50. So square root. So c is 50. And that's kilometers. That's 50. And our direction is southwest. And we can do southwest like that. This won't be on the quiz, but this is a challenging kind of thing, and it is in your geometry class, so this is kind of like an interdisciplinary thing, and it will be in our lab tomorrow. So you'll need this for your lab.